So we have non-vertical line equations, okay? And the reason these are non-vertical line is a vertical line, if you recall, is up and down. That's vertical. And every vertical line has the same form of an equation. Not the exact same equation, but the same form of an equation, and that's x equals some number. Okay, so if you have a vertical line, it's going to be x equals some number. And the number that it equals will be wherever it hits that x-axis. So if it hits the x-axis at 2, the equation of the line is x equals 2. If it hits the x-axis at negative 200, that's the equation, x equals negative 200. Okay, so that's vertical lines. Every other line can be written in a couple different forms. We have slope-intercept form and point-slope form. And you've seen these before? Remember that? Vaguely? Y equals mx plus b. Y stays a letter. M is your slope. X stays a letter. And b is your y-intercept. So m and b are going to be numbers. So as an example, y equals 3x minus 5. This is an equation of a line in slope-intercept form. My slope is 3. My y-intercept is negative 5. And the y-intercept is where we hit the y-axis. Okay. So if I were to graph this line, it's going to hit here at negative 5. And it's going to have a slope of 3, so it's going to be kind of steep, like that. And we'll talk about how I did that in a little while, but just right now, understanding what the format is. The other major form we have is the point-slope form. You have y minus y1 is equal to m times x minus x1, where this y is just a letter, and this x is just a letter. So they stay x and y. M is your slope. Can you guys read that? Green, is it okay? And then this x1 and y1 is a point on the line. And it can be any point on the line. So this is a number, and this is a number. So it would look something like maybe y minus 6 is equal to 2/3 times x plus 5. And I put the plus in here because, see how it's supposed to be minus? If you see a plus in this, that means the number was negative. So the point in this instance would be negative 5, 6. And my slope would be 2/3. The only real difference in these is that they're both telling me a point on the line. It's just that this is a specific point on the line. This point right here, which is 0, 5, negative 5, thank you. It'll always be 0, some y value. It's telling you a point on the line, it's just, it's a very specific point on the line. Whereas this formula, need that one there. This formula down here is any point anywhere on the line. It could be the y-intercept, it could be a point you know, over in this section. It could be up here in this section. It could be back here. It can be anywhere as long as it's on the line. Is the same line can have equations that look different. So for example, if I have some line y equals 3x plus 2. The point on this line is 0, 2. But I could also have y minus 5 is equal to 3 times x minus 1. This is the same line. It's just a different point on the line. This point is up 3 and over 1 from this point. That's the only difference between, and there, I could do this with any point on the line, but it would be the same line. So sometimes the same line can look different depending on which format you're using, which point you're picking. And the reason I'm saying that is so that, you know, if you were given a graph and I was told you like this graph here, and I said, write the equation of this line, depending on what point you picked, it could look different. That doesn't mean it's wrong. Okay. Start. We're going to write an equation in slope-intercept. So that's the y equals mx plus b with a slope of 3 and a y-intercept of -2. Now in this one I've given you the slope and I've given you the y-intercept, so there's not any calculations to do. It's just a plug-in sort of a situation. My slope is 3. That goes right there. My y-intercept is -2. That goes right there. Okay. -2 because it was negative. You could if you wanted to. It wouldn't be wrong. It's just like a little awkward. You could do it that way. It's not wrong. So they're the same thing. Now we want to graph it. This is our starting point. Okay, so we start at -2. It's on the y-axis. Okay, so you're going to graph that first. Then from there, these are our directions. My slope is 3, excuse me, which is the same thing as 3 over 1. If you ever have a whole number, just put a 1 underneath it. Because it's positive, that tells me to go up 3 and then over 1. If you forget to put the 1, then you'll just go up 3 and you'll still be on the y-axis, and that's now you're graphing a vertical line, and that's not what you want. You don't want a vertical line because vertical lines are all x equals some number. So always be sure to use that 1. So from this point right here, I'm going to go up 3. So 1, 2, 3, and then over 1. So that's the second step. And then the third step is to connect the dots. And I know you guys all know how to do that because everybody in here has played connect the dots at one point or another, right? You guys all connect dots, dot. And you know, your lines will be nicer because you can see what you're doing. Okay? Next one. My equation will be y equals slope. Yeah, y equals mx plus b, so y equals 1/2 x plus 5. Okay, so I'm starting at 5, and my slope is 1/2, so that tells me to go up 1 and over 2. So I go up 1, over 2. I'm just going to go backwards so I can draw something of a straight line. See, you can't even do that. And there's my line. Pretend it's straight. Okay, y minus y1 is equal to m times x minus x1. I have a slope and I have a point. This is x1, y1. So I'm going to plug my slope in here. I'm going to plug x1 right there. And I'm going to pick a different color. I'm going to plug y1 right here. So instead of being y minus y1 is equal to m times x minus x1, I'm going to have y minus 5, because I took the y1 out and put the 5 in, is equal to negative 3/4 times x minus negative 2. And anytime I have a minus a negative, it's a positive. Okay. When I'm in this format, the point negative 2, 5, opposite signs of what you have here. This is my starting point. So instead of starting at the y-axis, yeah, because see how it's always a minus? So if I have a minus and a plus, then my point is a negative and a positive. So whatever signs are here, the point has the opposite signs because of these minuses here. So this is my starting point now. So instead of starting at the y-axis, I just start at the point that's in the equation. So instead of starting wherever the y-axis is, I'm going to start at negative 2, positive 5. Yeah. Oh, equation. I was E-Q-U-A-T-I-O-N. There you go. Better. From there, so that's the first thing. And then the second thing I do is I count the slope. So since I'm negative 3/4, I'm going to go down 3 and then over 4. So 1, 2, 3, 1, 2, 3, 4. And then I put my next dot. And then my third step is again to connect the dots. If I can even sort of draw a straight line. It just has a different starting point, but the same basic idea, right? So let's try another one. We'll call this x1, y1. So I'm going to have y minus negative 6 is equal to 4 times x minus negative 3. These are happy, so they're positive. Okay. My point to start with is right here. So I'm going to start at negative 3, negative 6. My slope is 4, which is 4 over 1, which means I'm going to go up 4 over 1. Connect the dots. I'm going to give you two ways to do this. Method 1 is going to be to use all equations. And method 2 is going to be a combination of a picture and an equation. Okay? Hold on one second. Okay, so Method 1. Okay, we're going to use the slope formula. To find the slope. Okay, so that'll be first. So I'm going to plug in, I have x1, y1, x2, y2. So I'll do negative 1 minus 3 over negative 2 minus 0. So that's going to give me negative 4 over negative 2, which is 2. Okay. The next thing you do is you're going to plug in an x and y and m and find b. Whoa, what happened there? Find b. Okay, I can pick either point. Do you guys want to use 0, 3 or negative 2, negative 1? 0, 3. 0, 3 is nice because it makes things go away, right? Zeros do. So I'm going to have y, m, x, b. I don't know b, so b stays a b. I'm trying to find b. But I plugged in x and y and m. So I get 3 is equal to 0 plus b. So b is just 3 on this one. Okay. What I now have is the equation of this line. And that's all I needed to do was to write the equation. Y is equal to 2x plus 3. This is m, which I found first, and this is b, which I found second. And this is the answer that we were looking for, the equation. Now the other way you can do this is with a picture. You have 2 points. Plot them. I have 0, 3, and I have negative 2, negative 1. Okay. And I have a slope 1, 2, 3, 4, 1, 2. Between those 2 points. So I went up 4 over 2. So that gives me my slope of 2. Okay. So right now, for the equation, just from this much of the picture, I have y equals 2x. I still need to find that plus b portion. To do that, luckily in this case, one of our points landed right on the y-axis, but let's say it didn't land on the y-axis. Okay, you're going to want to use a ruler if you're going to do it this way because you want it to be very exact. And my slope is 2, so I would go up 2 over 1, up 2 over 1. And make sure I had enough points that I could get a really nice exact line. Draw the line through the points, find the spot where it crosses the y-axis. Find that spot right there. And that is 3 in this case, which luckily, like I said, our point landed right on there, but if it hadn't, we would have just connected to whichever points we had. Find where it crosses the y-axis and plug that in. So like I said, there's 2 ways to do this. You can do this the algebraic way, where you do just calculations and you don't have to draw any graphs or graph anything, or you can make a graph and find the information you need from the graph that you make. I got the same result, right? So whichever way makes the most sense to you, you're more than welcome to use. So we'll do those both again. So we'll do algebra over here. and pictures over here. Okay. x1, y1, x2, y2. So my slope is going to be negative 4 minus 4 over 9 minus negative 7. That's plus 7. So I have negative 8 over 16, which reduces to negative 1/2. And it doesn't matter which of these points you pick, you'll get the same answer because they're on the same line. So you can pick either point. You pick the one that you like the numbers better. Doesn't matter which. So negative 7 positive 4 or 9 negative 4? Any preference? Second one? Okay, so I'm going to do negative 4 is equal to negative 1/2 of 9 plus b. Half of 9 is 4 1/2. So I'm going to add 4 1/2 to both sides. And I'm going to get b is equal to 0.5. Now we don't like to mix these halves and decimals. You want to either keep like all fractions or do all decimals. So that's a half. So I'm just going to make it a half and it'll be nice and match. Now from the picture, this is where you're going to have any kind of difficulties with the picture, is you're not going to get an exact slope or exact y-intercept on these if it doesn't hit at an integer. We can still do this. We can plug our points. No, I can't. Okay, negative 7, 4. It's right there. If I had bigger graph paper, it would be no problem. And then 9, negative 4 is like over here. And I'm going to go down from 4 to negative 4. I'm going down 8. And I'm going over 16. So I'm still going to have the negative 8 over 16, which is going to give me negative 1/2. On a real piece of graph paper where you had more space, it would work. Then I'm going to connect the dots. And as I connect the dots, you can see I'm not going to go through an exact spot here. When that happens, I'm going to have to guess. That won't always work. For example, on a standardized test. But you will have still gotten your slope from the picture, so you could still do this half of the problem if you need to, where you plug in. You just didn't have to do this part. So I got the slope from the picture, so I do the negative 1/2, and I pick either of the points again. And I'm just going to use the other point this time to show you that you get the same answer no matter what. Half of 7 is 3 1/2. And if I subtract 3 1/2 from both sides, I get a half. Okay. So sometimes you might have to combine the pictures and doing some algebra as well if you don't get an exact answer. Form. You know what I found out too? People have a real preference. People like point slope, or people like slope intercept as well. Maybe don't like, but prefer. People have a real preference. I personally like slope intercept better. I don't know why, I just do. But you know, if you like point slope form better, that's okay too. Like whichever one you like better is fine. With this one, there's also, we can do the two methods. Let me pull some graph paper in. We can do it the algebra way. So again, the first thing we have to do is the slope formula. Okay, so x1, y1, x2, y2. So I have 10 minus 4 over 8 minus negative 2, so that's plus 2. So 10 minus 4 is 6. 8 plus 2 is 10. And I'll reduce that to 3/5. Then I plug in either point. Which one do you guys like? 8, 10, okay. Y minus 10 is equal to my slope 3/5 times x minus 8. Done. You don't have to solve for anything on this one in the second half. You just have to plug it in all correctly. Now if you wanted to do this graphically, I could plug in the points. Oh, I have bad points again. Yeah, I plug in the points. I have negative 2, 4. And I have 8, I don't know, 10. I'll just say that's 8, 10. I have no idea where it actually falls. We'll pretend it falls there. And if I count up from here, I'm going to go up from 4 to 10. I'm going to go up 6. And from negative 2 to 8, I'm going to go over 10. So I'm still going to get 6 over 10, which is still going to give me 3/5. I'll still have my slope, but then I do the same exact thing. I just plug it in with one of the points. It doesn't matter which point. You'll have to find the y-intercept on this one. Okay. My slope so I'm going to do 3 minus 3 over 7 minus negative 1, and I'm going to get 0 over 8. 0's on top. That's okay. So my slope is 0. Which point would you like? The first one or the second one? Okay, y minus 3 is equal to 0 times x minus 7. We don't really, I mean, you can keep it that way. It said to do it in point slope form, so that's fine. You can leave it like that. Really, this is y minus 3 equals 0, and really that makes it y equals 3. And that's kind of the more simplified version of it, but either of these would be fine. And then if you did this on the graph, I'd have negative 1, 3. And I'd have 7, 3, and I'd have a flat line, so I'd have no slope. So I'd end up with the same thing. All right, I'm just going to skip this part up here, and I'm just going to tell you about the horizontal and vertical line equations. So, give myself more room. Okay. Horizontal lines are flat, right? And they cross the y-axis because they go this way. So their equation is always y equals some number. And this number is the point where the line crosses the y-axis. It's the y-intercept. So it's always y equals the y-intercept. And then we have vertical line. Vertical lines go up and down. And they cross the x-axis. And so the equation on these, x equals some number. And this is the point where it crosses the x-axis. Which is known as the x-intercept. anything. But if you take an h and you erase this part of it right there, it kind of looks like a y. Horizontal line kind of looks like a y. And if you take a v for vertical line, well, it's sort of the top half of an x. That's the best I could come up with. Sorry, not good, but that's the best I could do. If anybody thinks of anything, though, let me know. Parallel or perpendicular equations. Now, we know that parallel lines have the same slope. And we know that perpendicular lines have slopes that are opposite. That's an O, not an A. And upside down. You know, negative reciprocals. That's a W. No, it's not. Now it is. Whatever. Okay, so we're going to write the equation in slope-intercept form for a line perpendicular to this line. So we have y equals negative 3x plus 2 through the point 4, 0. Okay. If our first slope is negative 3, our perpendicular slope is going to be positive because the first one was negative, and then we need to flip it over. So instead of it being a 3, it's going to be a positive 1/3. So here's our slope. And we need to put it through the point 4, 0. So we do this usually algebraically. Y is 0, m is 1/3, x is 4, and I find b. Okay, so 4, 0, m. Okay. To multiply this, I just multiplied times the whole number. The numerator times the whole number gave me a 4. And then I subtract 4/3 from both sides. And luckily, 0 minus 4/3 is just negative 4/3. That one was easier because of the 0. That's b. Oops. There's the equation. Okay, so the first step is to find the correct slope. You know, if it's parallel, it'll be the same. If it's perpendicular, you flip it over and change the sign. Then we plug in and solve for b. And then we plug both the slope and the b in to get the equation. So here we're looking for parallel. My first slope is negative 3/4. My parallel slope is going to be negative 3/4. Y is 6, m is negative 3/4, x is negative 3 plus b. Now in this case, I'm going to actually have to deal with some fractions. To make it work. So I'm going to make this 6 into 4ths. To do that, whatever denominator you want, you multiply that times your whole number. So 24 over 4. So I'm going to take this 6 out and put 24 over 4 in. They're the same thing. Add 9/4 to both sides. And I'm going to get 33/4. And guess what? Leave it like that. I don't need you to convert that to a mixed number or a decimal or anything. Just leave it like that and plug it in. Oops, not negative 9/4. Okay? All right, so for homework, finish 37 and 38 that you guys started yesterday in the packet and go back and look at it. We'll go over this on Monday. And also, like I said, I'll bring in a little bit more of that slope practice as well.